Hey Pre-Calc, welcome back. Our objective today is going to be to apply the last three kinds of trig identities to simplify or evaluate trig expressions. I'm going to force pause on your screen, make sure you double check the checklist, but also make sure that you have got your formula sheet on you. Alright, I'm going to force a pause on your screen. Can you just go ahead and write sine of u plus u? Okay, we are back. So what I'm going to do is actually derive the double angle formula for you for sine of u plus u. So think of this in your formula sheet as u and this as v. So since Sinbad is driving, I've got Sinbad and Cosette in the front seat, right? But remember, I'm plugging in u for both u and v in this case. Sinbad's driving, so signs are the same. And then Sinbad's brother and Cosette's sister are both in the back seat, right? So notice I have sine of u, cosine of u, plus another sine of u, cosine of u. So essentially I've got 2 sine of u times cosine of u. And if you'll take a look at your formula sheet for me, that is indeed what we get for sine of 2u, which is u plus u. So that is, again, kind of how we derive sine of 2u. That's a double angle identity, and you can follow the same idea for cosine of 2u, okay? So let's try some examples together. Okay, I'm going to force a pause on your screen. Can you copy what I have, and then we'll work this one together. Alright, so I want to find sine of 2x, given that sine of x is 12 over 13 and x is in quadrant 1. So whenever you see something like that, always draw out what you're given, okay? So x is in quadrant 1, so I'm just going to draw a general triangle in quadrant 1, label the reference angle x, and sine is opposite over hypotenuse. We can use Pythagorean. One second. Okay, we're back. So the remaining leg here should be 5, and do you want that to be positive or negative 5? We'll keep that positive 5 because we've gone to the right. So now that we've got the triangle completed, let's go ahead and look at our formula sheet. We are going to use the third box, okay? And we want to use sine of 2u. And notice that we're choosing an x instead of a u. So you're going to take that top formula and just replace all your u's with x's. Notice you've got 3 different formulas for cosine of 2u. They're all equivalent, so you just use whichever one is more convenient to use for the information that was given for that problem. But for sine of 2x, we saw that that was 2 sine of x times cosine x. So this 2 is going to come with us. Now let's come to our triangle that we drew to find sine of x. So sine is opposite over hypotenuse, which according to our drawing is 12 over 13. And cosine is adjacent over hypotenuse, so again 5 over 13. And make sure that you're just taking the ratios here, so it's not sine of 12 over 13, right? It's that sine of x is equal to 12 over 13. So I replace this with this, just like I replace this with that, okay? So make sure your sine and your cosine are gone at this point. Now we can just multiply straight across. So 2 times 5 is 10, times 12 is 120, and 13 squared is 169. All right, let's practice those remaining 2 boxes as well. Can you please write in your notes cosine of pi over 12? And I'm actually going to force pause on your screen. Go ahead and copy exactly what I have. Okay, so for pi over 12, notice that that is a bit too small, right? It's if I were to double it, I'd get pi over 6. That's on the unit circle, and I can work with pi over 6. So let's first find what u is. If you look at your half angle box there for your formula sheet, notice that it is like sine or cosine or tangent of u over 2, okay? So if I want to figure out what u is, I actually need to take my argument here and multiply by 2. Okay, so if I take pi over 12 and multiply by 2, I get 2 pi over 12, which reduces to pi over 6. So that's my u, because u over 2 would be pi over 6 over 2, which is pi over 12, okay, which is what I was trying to get back to. So just keep in mind, this is not u, okay? U is that stuff in parentheses times 2. Okay, so let's work with our formula. We've got cosine of pi over 6 over 2. So again, u is pi over 6. So notice that your formula, it starts with a plus or minus. So what I need to do is come to this pi over 12 and decide what quadrant is that in. So what do you think? What quadrant is pi over 12 in? Pi over 12 is in quadrant 1. Well, all the 3 trig terms are positive in quadrant 1. So I'm going to choose the plus sign there. Okay, and now let's keep going with our formula. So I've chosen the plus, then it goes 1 plus cosine of u, which remember is pi over 6, so cosine of pi over 6 all over 2. Okay, and now we can just simplify that. Cosine of pi over 6 over here, so that is root 3 over 2. Still have that all over 2, okay? So let's clean this up a little bit. We don't really like to see fractions inside fractions, so let's go ahead and work with this piece first, right here, okay? Notice that I need a common denominator of 2. So let's make that 1 a 2 over 2. Let's keep working with that. So I've got square root. Still have this 2 in the denominator. Now I have a common denominator of 2, so I can add the numerator straight across, which will just be 2 plus square root of 3. Okay, almost there. Again, just making this look a little bit nicer. So I've got that. Then I've got this divided by 2 in the denominator here, which is the same as multiplying by the reciprocal 1/2. So I'm getting square root of 2 plus square root of 3 all over 4. And the last simplification I can do is the denominator simplifies to 2, right? So that is our final answer in exact form. So the last thing we're going to look at are the power reducing formulas, and these come in handy in calculus because it is typically much easier to look at sine, cosine, or tangent with a power of 1 as opposed to any other power. What I want you to really pay attention to here is whatever your input is, like u here, you double it on the inside, okay? So if I were to start, if my u were like a 5x here, in here it would end up being a 10x, okay? So I want you just to kind of be mindful of that. I'm going to force a pause on your screen. I just want you to take a look at the power reducing formulas before we get started. So go ahead and write sine to the 4th of x in your notes. And what we want to do is reduce this or rewrite it to the first power of cosine, okay? So I don't want any exponents in my final answer. So here's what I'm going to ask you to do. Can you rewrite this as sine squared x times sine squared x for me? And now let's go to our power reducing and plug in what sine squared of x is equivalent to for both. So if you look at, again, we're here. If you look at the first formula here, we've got that sine squared x is 1 minus cosine of 2x all over 2, right? And I've got that twice. Okay, just to make this easier on the eyes, I can see that the denominator 2 times 2, I've got a denominator of 4, which is the same as multiplying by 1/4 on the outside. So I'm going to bring those denominators out, again, to make it a little easier to see the rest. So the rest is 1 minus cosine of 2x Okay, now don't be fooled because it looks maybe that we're in the first power of cosine, but we're not because I've got a cosine of 2x. Let's see here, I'm gonna grab my mouse. I've got cosine of 2x times another cosine of 2x, which is ultimately a power of 2. Okay, so let's go ahead and distribute now. So I've got the 1/4. 1 times 1 is 1. Then I'm going to have minus cosine 2x and then minus another cosine 2x, so minus 2 of those. And then my last term will be a negative times a negative, so that's a positive. And I've got cosine of 2x times itself, so that's a squared, cosine squared of 2x. So you can see here, this is the problem right there, right? So here's what we need to do. We're going to go back to our formulas here. This time look at the second formula in the last box. And now what I need to do is apply that formula to this piece only, okay? Now remember I told you to be very mindful of what is your u in this case. What's your input? It's 2x, right? So when I apply that formula, remember I double it. So what am I going to end up having? I'm going to end up having 4x, okay? So be careful, write what I have, and let's see if we can follow along here. I've got 1 minus 2 cosine 2x still, plus, and here's where I need my formula, right? So I'm using that second formula. So this is now 1 plus cosine of 4x, right? Because it's 2 times 2x all over 2, okay? And while it's not the cleanest, and I could clean this up a bit, I'm going to let you keep it like that because we've followed the directions. We rewrote the expression in terms of the first power of cosine, okay? You're going to get more practice on this in class, but bring me questions that you have, and I will see you all next time.